I'm Roman Rodrigues and we are on chapter 10, Heat, and we are doing lesson 5. In the previous lesson, I explained to you about Boyle's law and Charles' law. Today we are doing the general gas equation, and the general gas equation is basically derived from both Boyle's and Charles' law. Now, according to Boyle's law, we know that volume of a given mass of gas is inversely proportional to pressure when temperature is constant, and according to Charles' law, volume of a given mass of gas is directly proportional to temperature when pressure is constant. Means that inversely proportional means that when you increase the pressure, the volume decreases. You decrease the pressure, volume increases. And directly proportional means increase in temperature, the volume increases, and vice versa. When the temperature decreases, the volume increases. So when you combine both these laws, Boyle's law and Charles' law, we get volume is proportional to T upon P, where alpha is the constant of is the sign of proportionality. Sign of proportionality. And when you remove this alpha, we put a constant, and K is your constant of proportionality. Now, when you cross multiply, we get PV and bring this T on the other side upon T is equals to K. Or we can write it down as P1 V1 upon T1 is equals to P2 V2 upon T2. We can, where P1 is the initial pressure of gas, V1 is the initial volume of gas, T1 is the initial temperature of gas, and P2 is your final pressure of gas, V2 is the final volume of gas, and T2 is the final temperature of gas. So P1 V1 upon T1 is equals to P2 V2 upon T2, which is your K, and K is your constant. Now, the value of constant K depends on the mass of the gas expressed in moles. For 1 mole of gas, the constant has a particular name, and it is called the universal gas constant, and it is denoted by R. So I can replace K as NR. R in SI unit, the value is 8.3145 joules per mole per degrees Kelvin, and for n moles of gas, the value of constant is NR. As I mentioned over here, the value of constant is NR. So I can write this equation now as if I can say P1 V1 upon T1 is equals to P2 V2 upon T2, and they all equals to PV upon T is equals to NR. So taking this as PV upon T is equals to NR, I cross multiply, I get PV is equals to nRT, and as I mentioned, R is constant, and depending on the number of moles, and the value of R is 8.3145 joule per mole per degrees Kelvin. So I hope it is clear. The gas equation, this basically is your general gas equation. Now I have one problem based on this formula that I've just put up over here. This is in your textbook, problem number 3. Just write down the data first. The question says that, reads that given mass and a pressure of 50 centimeter of mercury is heated from 27 degrees centigrade to 97 degrees centigrade. So the pressure, initial pressure is given to you, 50 centimeter of mercury, and is heated from, the initial temperature is 27 degrees centigrade to 27 degrees centigrade. If the volume is maintained constant, volume is constant, according to this is same, calculate the pressure exerted by the gas. You need to find final pressure. is equals to how much centimeter of mercury. Now, since it is Kelvin over here, so we'll have to convert centigrade into Kelvin by adding 273. So this will give you 300 Kelvin, and this will give you to 97. This is right, pressure from 27 to 97. So this will give you 3 into 10, 9, 10, 17, 370 K. Now, applying these values in this formula, let's see what do we get. P1 V1 upon T1 is equals to P2 V2 upon T2. Initial pressure is 50. Volume, they said that it is constant, so V1 V2 will be same. Over T1 is 300 degree Kelvin, and P2 we need to find out. Volume, as you know, is the same, and T2 97 plus 273 will give you 370. Yeah. Volume is constant, they can cancel, and we need to find P2, so let's bring 370 on the other side. 50 times 370 divided by 300 is equals to P2. These two zeros will go with these two zeros. 5 sevens are 35, 5 threes are 15, 16, 17, 18 divided by 3. So 185 divided by 3 will give you 3 6 are 18. 3 ones are 3, 6 are 18, 6 6 6. So you have P2 is equals to 61.67 centimeter of mercury, right? Centimeter of mercury. This is the answer. I hope it is clear to you all, and we'll be doing few more problems based on combined gas law, our next lesson. Till then, take care.